Hi, I'm Mrs. Alspaugh here with Mr. Mack, and we want to welcome you to the third video in OCCRA's Robotic Video Guide.
You know, we've been learning about voltage, but did you know voltage and current are not the same thing? We've got some students out at the campus who are going to show us a little bit more about current and how you have overload protection on your robot.
Hi, I'm David, and this is Naya from team number 1 Juggernauts.
Today we'll be talking about current in electric circuits.
Now, First Robotics and OCCRA Robotics basically has the same circuits.
Voltage measures the push, or EMF, to move the electricity along.
Current measures how much electricity actually flows.
Current is measured in amps.
Are you ready to take a closer look at current?
I'm all lamped up.
Current must have a path or route to follow.
The route followed by the current is called the circuit.
What flows are electrons, tiny negative particles found in all atoms.
It's possible to have current with almost no voltage and vice versa.
This battery is not connected to anything, so there's almost no current leaving it, but you can still read its voltage.
The circuits on your robot begin with the negative battery terminal.
You should tape the terminals to prevent any accidental short circuits.
Black is the color code for wires that connect towards the negative terminal.
In electric currents, while negative electrons flow in one direction, positive charges always move in the opposite way.
People who talk about the classic current are treating electricity as flow of positive charges.
We will consider electricity to be a flow of negatives.
Are you sure we want to use classic currents?
I'm positive.
Current from your robot's battery only flows in one direction.
So we call it direct current, or DC. The electrons leave the negative terminal of the battery to flow into the control box, out of the robot, and return through this red positive wire.
We reference all of the voltages in the control box to the negative battery terminal.
So we refer to the black cable as our ground line.
Even though it never actually connects to the ground.
This black number 6 battery cable attaches to the long terminal strip that we call negative or ground strip.
Notice that the ground strips have about 10 smaller black wires screwed into it.
These black number 14 gauge wires carry the current to all of the robot's electrical components.
And these red number 14 wires also connect to all components. They carry the current back to the battery.
A switch interrupts the current by breaking the circuit.
Circuit breakers like this are switches.
Every control box contains a 120 amp circuit breaker where the battery cables enter the box.
If your robot starts to draw too much current, the circuit breaker will flip like a switch and turn off the power automatically.
Or if you just need to kill the power quickly, push the red button on the circuit breaker.
Once you've killed the power, you can turn it back on by simply flipping the reset lever back up.
Remember, when you're making your robot, make sure the power off button is easy to get to.
The most important thing to remember in this video is that all power wires need to be firmly connected.
If you have a connection where you can wiggle the wire even a little bit, it means that the current that can flow through the connection will be greatly limited.
And the robot will behave as if the battery is almost dead.
The other devices on your robot that protect against too much current are called fuses.
We will talk more about them in another video. Bye for now.